Hey, year 11. So the next thing that we're going to look at is the cardiovascular system. Quite tough to do in 6-7 minutes, but we'll see what we can get through. Okay? So the first thing that we look at, the cardiovascular system, is the heart. Okay? And everything associated with your heart. Now this big picture of the heart on the screen is how we need to look at it. It says, oh, it's my heart now. Okay? So the right hand side is currently here, the left hand side is there. Okay? And that'll be in the middle of my chest. So the first thing that we're going to look at when we look at the heart is going to be the actual structure of it. Okay, we'll miss the valves out for now. I would recommend your key booklet for this one so you can read through as I'm talking. Okay, but anyway, as it is, we've got on the right hand side here, we'll start with the right ventricle. Okay, that's the area there where the blood is pumped into. We've then got the right atrium. So imagine the heart as a circle, and if you cut it into four, you'll have four sides to it. Right atrium, right ventricle, and you've got the left ventricle on the opposite side, left atrium. Okay, that's a simple way of looking at it, like a circle, put a cross in the middle of the circle, and you've got a nice section of the heart there, really. Okay, we've got the septum. That is the piece of muscle in the middle of the heart that splits the two ventricles up. Without that, we wouldn't be here. Okay, the septum, think about separate. Septum separates. Okay, then the other structures of the heart. Now then, we've got the aorta, which has got these three areas coming off it. We've got, I don't want to cover the other stuff out of valves, we've got the vena cava, which is straight up here. It goes all the way through the heart up to the top as well. So the vena cava is noted at the top. And we have also got the pulmonary artery, okay? The only artery that carries deoxygenated blood. And then we've got the pulmonary vein, which is the only vein that carries oxygenated blood. Veins normally carry deoxygenated blood, arteries, oxygenated blood, apart from them two that we've just noted there. Okay? The next thing that we look at then, once you know the structure of the heart, you need to know that structure. Okay? You need to be able to pretty much draw it. The key ones are the aorta, the pulmonary artery, whereabouts they fit. Because like we said, if we draw the circle and put the cross on it, you can't go far wrong with that for the build-up of the heart. It's the other things around it that you need to know. The next bit, I'll come to this side, is the valves. Okay? Need to know why we have valves. Valves ensure blood flows in one direction only. Okay, if it starts coming back, no good. They prevent blood flowing backwards. That's why we have valves. That was a question on one of the mock papers. Now then, the way we remember the valves is nice and simple. It's an acronym, LAB-RAT. Okay, left atrium is a bicuspid valve. Right atrium is the tricuspid valve. Okay, I'm going to move to this side so we can see where we are. So, the tricuspid valve then. When we're looking at that acronym that we've got, LAB-RAT, the right atrium, we're going to find the right atrium on the heart. This is then our tricuspid valve, and it says that in your key booklets for you. Okay, it's between the right atrium, right ventricle. Then, as you can see, the valves run across the middle of the heart as well. We move to the opposite side, the lab part of LAB-RAT, and on the left-hand side, we've got the bicuspid valve. Okay, that one again is between left atrium, left ventricle. Now there's two other valves that we need to know, and that's these two here. Now the collective name, that means the name for both of them together, is the semilunar valves. But individually, we've got, as you can see on the side, the pulmonary valve, and we've got the aortic valve. Now the pulmonary valve is in the right ventricle area here, okay? The pulmonary valve is this one. It goes in the pulmonary artery, which carries deoxygenated blood, the only artery that does. And then on the opposite side, we've got the aortic valve, which is coming into this bit here. Sorry, I was pointing up there, then my bad. In the left ventricle here, blood's going to go up through that to the aorta. Okay? And that is your oxygenated blood going through there. So, that covers our valves for us. Next bit, key parts of the cardiovascular system then. We've got stroke volume, normally known as SV. We've got heart rate, HR. This is when the heart contracts and relaxes, which is a heartbeat. Heart beating that. Stroke volume is how hard your heart beats. So how strong the actual heartbeat is, whereas heart rate is how many times it's beating. Cardiac output, now that is the combination of stroke volume and heart rate times together. So whatever they equal, that gives you your cardiac output. Now the GCSE, they know that as Q. Don't know why, but that's what they're referring to it as Q. Okay? So your cardiac output is the overall of heart rate times stroke volume. So the next thing that we go on to then is the double circulatory system. That is this whole the circulatory system that involves cardiovascular system, and it involves the lungs, but we relate it to this cardiovascular system for now, okay? That's this drawing on my right-hand side. As you can see in your key booklets, it's a heart. It's very simplified though. And basically all you need to know, the top system is your pulmonary circulatory system, okay? That's everything going to the lungs and then back to the heart. Whereas below that black line there, the lower below your heart is a systemic circulation. Now we said, remember that submarines are below the water, planes are in the air, so the P stands for pulmonary and the S for submarines is systemic, okay? So we'll look at the pulmonary circulation and we'll read it. Basically, the first part, transportation of blood between the heart and the lungs. That's up here. The pulmonary artery takes deoxygenated blood to the lungs, and then once it's got the oxygen, it comes back, it offloads its carbon dioxide into the lungs, and it's taken back to the heart via the pulmonary vein. Okay? So that's them two there. We've covered above that line. We then go to the systemic system. Now then, blood is pumped from the left ventricle into the aorta. Again, I'm looking at this because I can guide you through it. The blood is then transported to the rest of the body via the arteries. Now that's signified by this, but they're all little arteries in your body. This bit here, instead of being your lungs in that system, this is your liver, your gut, your kidneys, your limbs, that's your arms, your legs, everything like that. That's your body, okay? Then the blood is returned back to the heart as deoxygenated blood and put onto the right-hand side. To finish off, so that's your double circulatory system. They will ask a question on that. We look at blood vessels, blood and blood vessels, okay? Remember this, a ship is a vessel, so it carries something, it helps something transport. So, we've got red blood cells, first of all, simple as they're the things that carry the oxygen, okay? They've got a lot of red blood cells in our body, and they travel through three things. We've got, first of all, arteries. Now, we know arteries, as you can see on the picture here, are very, very thick. You can see them there. They're made for high pressure blood going through them, okay? Veins, on the other hand, they're a bit thinner. Now, they're made for lower pressure blood going through. Now, we know veins carry deoxygenated blood. Finally, we've got capillaries. These are the small things that allow blood to transfer oxygen and carbon dioxide. They allow for diffusion, okay? When we look at arteries as well, there's a little thing over this side. It's talking about vasodilation and vasoconstriction, okay? Basically, that means when they increase, that's vasodilation, that's increasing in the strength of them, okay? Whereas when they vasoconstrict in diameter, that means they relax and it lets more blood go through them, okay?